All righty, folks. How y'all doing? Good to see you guys. Now we are here once again. We're just kind of moving our way through this idea of series and sequences. And today we're going to look at one special type of sequence. And this one is called an arithmetic sequence. Now, an arithmetic sequence is they're really closely related to linear functions. Okay, they kind of go hand in hand. And the reason why is for linear functions, they have this idea of slope, which is that same jump repeatedly. Well, arithmetic sequences has that same idea of slope, but they call it common difference. Common difference and slope, they're pretty much the same thing. So again, that's kind of a big deal. Common difference and slope are the same thing. So now, if you notice, we have a common difference here, we have our slope here. Also, this idea of the initial value, and for linear functions, the y-intercept, those are really close to being the same thing as well. So when we have our sequence, there's our initial value, and here's our y-intercept. So they're really primarily the same exact idea. It's just instead of x, we call it n minus 1, or the term number minus 1. So what we're going to do today is we're going to play with this idea of arithmetic sequences and see what we can come up with here. Oh, I didn't mean to have that there. There we go. So given the rule of the arithmetic sequence, so we have this rule. It says determine the initial term. So the initial term, remember, is a sub 1. So if I take 1 and I plug it in my sequence there, I will have the initial term. So 7 plus 8 times 1, that'll be the initial term. So my initial term then is 15. Notice, it's not 7. That's the 0th term, if you wanted to look at it. When n equals 0, that's the 0th term, which is the idea of a y-intercept, because x is 0 for a y-intercept. We're not dealing with a 0 term. Initial term is the first term. The common difference, now that's the slope. Remember, common difference, d, equals the slope. So in our problem here, 8, that is the slope of that equation, so therefore that's the common difference. So the common difference would be 8. So the first thing we got to be able to do is we need to be able to interpret what's going on a sequence and be able to figure it out. All right, so given the sequence, determine the arithmetic rule. So remember, whenever we're writing a sequence rule, it's always a sub n equals the initial term plus n minus 1 times the common difference. So we know what a sub 1 is. That's that value right there. That's the 4. What we're looking for here then is the common difference. There we go. Now the common difference is always the second number minus the first number, if it's repeated addition. So one way to look at it is, well, what are you adding repeatedly over and over again? Because if it's not the same number, then it's not an arithmetic sequence. But if you notice, we're adding plus 7 over and over again. So if you know it's arithmetic to begin with, you just take your second number to subtract your first number and you have it. So either way you can get it, doesn't matter. You can look for that repeated addition number, or just take, if you know it's arithmetic, take the second number and subtract the first number from it. So we know what that common difference is. We're going to plug that in. So to get my rule, my arithmetic rule, or just my sequence rule, I get 4 plus 7n minus 7, and we end up with 7n minus 3. So that would be our sequence rule. Now in the second part of this, we're looking for the 25th term. So in other words, we're looking for what a sub 25 is. Well, now we know what our rule is. This isn't too bad. Just literally plug in 25 into your problem. So 7 times 25, that's 175, and subtract 3, and you end up with 172. So arithmetic sequences. All right, let's play with this just a little bit more here. Let's see if you guys can't do a little bit of this yourself. Why don't you guys go ahead and pause the video and see if you can't take a look at the third one. All right, let's see how you did. First up, is it actually, looks like I'm subtracting 6. I'm subtracting 6. Yeah, it looks like that's the common difference. It is arithmetic. So D equals, the other way to do it would have just been second term minus the first term. So I'm going down. And the very initial value here, that is my a sub 1 value. So a sub n equals a sub 1 plus n minus 1 times d. And if you've learned the point slope form, that's really all this is just the point slope form for a line. That's all we're doing here. So 13 plus n minus 1 times -6. So we're working our way down, getting our sequence rule here. So 13 minus 6n plus 6. So that sequence rule would be a sub n equals -6n plus 19. And now the 30th term. So once we have that, it's not too bad. So a sub 30 is -6 times 30 plus 19. So -180 plus 19, that would be a -161. So we're just kind of cruising through this pretty good here. Well, now we get to something a little bit more, something's going to make us think a little bit more. We're told the 13th term is 41. And we're told the 19th term is 65. So in other words, let's see what we got here. The 13th term, that's 41. And the 19th term, so a sub 19, that is 65. And we're asked to figure out what the rule would be. Well, now, friends, if we remember that the rule is a sub n equals a sub 1 plus n minus 1 times d, there's a couple ways you can go about doing this. You can do this as a system of equations if you wanted to, or instead of looking at it as function values, the way I usually look at it is, what if we just treat them as points? Remember, if these are related to lines, and common difference is really nothing more than slope, then I should be able to find the slope of these 2 points to figure out what my common difference would be. So let's do that. So y sub 1, subtract the y's, y is 2 minus y1, over subtract the x's. So x2 minus x1. So subtract the y's over subtract the x's, we get 24 over 6. That means every time I'm going up, I'm jumping up by 4. That's my common difference. So that means a sub n equals a sub 1 plus n minus 1 times 4. Well, I still don't know what the first term is, but what if I were to plug in one of my numbers? What if I were to plug in 41 in for a sub n? I know that that is my 13th term. So if I plug those in, just like we plug in a point, we could find the y-intercept, or in this case, we'd find what the initial term was. Minus 1 equals 4. So really all we're doing here is just finding the equation of a line. plus 12 times 4. So 41 equals a sub 1 plus 48. Negative 7 is equal to a sub 1. So that's my first term. So now I know my first term. I know my common difference. Friends, I can now go ahead and come up with the actual function rule, the sequence rule. So a sub n is negative 7 plus 4n minus 4. And that ends up being 4n minus 11. So we have our sequence rule. Now, friends, we can figure out the 101st term. So we plug it in here, 101. We're going to plug that in for n. We're going to subtract 11 from it. So the 101st term is going to end up being equal to 393. All right, arithmetic sequences. They're not too bad. Find your arithmetic rule, and then you can get your common difference in your initial term and use that to get your sequence rule. Well, let's keep going here. Sometimes we want to find the sum of a set number of terms. And if we want to find the set number of terms, we have this handy-dandy little equation here. Some people will use this one over here. I don't know. I've always just like the simplicity of n times a plus 1 plus a sub n all over 2. I always kind of like that. Actually, there's a lot of parallels between that and a trapezoid. Because remember what a trapezoid is. Area is height times base 1 plus base 2. So our bottom base plus top base divided by 2. A lot of similarities between these two. Anyways, let's see if we can actually deal with this here. I'm told that I have 25 odd integers. So friends, that means that my n value is 25. And they're going to be between 1 and 41. That means a sub 1 is 1. And a sub 25 is 49. So if I want to find the sum of all these numbers, instead of going to my calculator and plugging them all in here, I can use this little equation here to figure out the sum. Turns out this is going to be 25, 1 plus 49, all over 2. So S of 25, so the sum of the first 25 terms is 25 times 50 divided by 2, which is going to be 625. I don't have to spend my time trying to figure out and keeping track of adding all the numbers. I can use this summation formula to be able to determine it. So it says find the sum of all the integers from 1 to 100. Well, notice 1 to 100, I'm counting by 1 here, so that means a sub 1 is 1. And a sub 100 is 100. So we're going to add up all these numbers. So that means then that I have 100 numbers. Definitely don't want to add all those up, but I could figure out the quick sum of it. So 1 plus 100 divided by 2. One of the ways I like to think of this is number of pairs. So if I were to like take 1 and 100 and add them up, I get 101. 2 and 99, I get 101. 3 and 98, I get 101. 4 and 97, I get 101. So all the different pairs, and there's 50 pairs, 100 divided by 2, there's 50 pairs. they always are going to add up to the sum of the first and the last. So now we have 100 times 101 divided by 2. And friends, that would end up being 5,050. All right, so hopefully we're kind of getting the gist of how this whole little equation works here. If we are, why don't you guys try to deal with number 3 and number 4. See what you guys can deal with those. Number 3 and number 4. All right, so let's pause it now. Now that you've unpaused it, let's see if we can't figure this out here. So first 27 terms. That means I'm dealing with 27 terms. I don't know my initial and I don't know my 21st, but I can figure it out. If I plug a sub 1 in for my n here, so a sub 1 is 3 times 1 plus 2. That means my beginning term for this particular sequence is 5. And I'm going to try to figure out what my 27th term is. '81 plus 2 is 83. So those are our terms. So we're going to plug it into our formula then. So the sum of the first 27 terms in this sequence is 27 times 5 plus 83 divided by 2. Multiply it all the way out, you end up with 1,188. How about this one? Number 4. Well, I'm looking at here, I see 75 the 75th partial sum, that means 75 terms. I see that my a sub 1 is 4. I don't know my 75th term, but if I do notice that my common difference is 8. I'm adding 8 every time. So I could go through and figure out what my 75th term is. Going back and using our sum. So 4 plus 75 minus 1 times 8. I don't actually need to get the full sequence rule for it. So we got 4 plus 74 times 8. So that means my 75th term would be 596. All right, so now we can go ahead and figure out our sum here of these 75 terms. So 75, 4 plus 596. I think these are kind of slick here. I mean, the idea that we can count up to 75 that quickly, it's kind of cool. And we end up with 22,500. All right, friends, we only got a couple left here. What happens if we put them in sigma notation? Now, there's something you need to that we haven't covered yet, which we need to do. We have our n value, and we have this beginning value. Let's go ahead and call it b. So I'm going to call, actually, we'll call this not n up there. I don't want to call that n. Let's give it a different letter. Let's make it k. K looks good. Turns out the number of terms in a sequence is always going to be k minus b plus 1. Let me show you what I mean here on this next one, 32 minus 1. If you take 32 minus 1, we know that that means that there's going to be 32 terms. But if you were to subtract them, look what happens. When you subtract the two, you end up with 31 terms. That doesn't mean there's 31 terms. I know that if I'm counting from 1 to 32, there's actually 32 terms. What it does mean, though, is that very first index number, we count that. So it's like 1 and then forward. For instance, when I count 1 to 100, I don't go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We don't do that. We just go right into our sequence of 1, 2, 3. Well, on an index, we actually have to count that starting value. That's why we always have to add 1 to it to be able to determine how many terms there actually are. So the way we figure out the number of terms, it's upper number minus the lower number, then add 1. So I know then that there's 32 terms in this sequence. What I don't know is what my first term is. So I got to evaluate for the lower value. And what my 32nd term is. I got to evaluate it for my greater value. So 2 times 1 plus 5, that is 7. 2 times 32 plus 5, that's 69. And if we plug these numbers in here, we'd have the sum. So the sum of the first 32 terms is 32 times 7 plus 69 divided by 2. $12.16. All right, take a shot here and see if you guys can't pause the video and try the next one on your own. All right, let's see how I did. First of all, we've got to figure out how many terms are in this. Notice, I'm not starting at 1 this time. I started at 7, right? It still works though. So 24 minus 7, so upper number minus the lower number, and then add 1 to it. So there will be 18 terms from the 7th term through the 24th term. All right, so we got to get the first term in our sequence. Funny thing is the 7th term is going to be quote unquote the first term in the sequence. So I plug that in here. And that first term that we're going to be starting with is -1. And we're going to go to the 24th term. And that would be -52. Now we can go ahead and figure it out. So the sum of these 18 terms, so there's 18 terms in this sequence that I'm adding up. The first term of the sequence is -1. And the second one is the last one is -52. So we're going to add them up and then we'll divide by 2. So the sum of these 18 terms would be -477. All righty, friends. So that kind of gives us a little glimpse of how this works. So why don't you guys go ahead and do me a huge favor. Go ahead and give it a shot, see what you guys can do, and then I will see you guys tomorrow in class.